we have less than 24 hours. Right now, as you hear these words, an object the size of Manhattan Island is plunging toward the sun at 60 kilometers per second. In a few short hours, on October 29th, 2025, it will reach perihelion, passing just 67 million kilometers from the solar surface. And when it does, we're going to get answers, or we're going to get silence. So this is potentially one of the most significant turning points in modern cosmic history, if this rock defies science during this specific time. Make sure to share this video to a friend so that humanity will know the truth. 3I Atlas, the third confirmed interstellar object ever detected entering our solar system, will reach perihelion, its closest approach to the Sun, 203 million kilometers. 1.4 astronomical units, just inside the orbit of Mars, and at that exact moment it will be completely invisible from Earth, hidden behind the sun's glare, unobservable, for 3 weeks. But here's what makes astronomers lose sleep. It's not just that we can't see it during perihelion, it's what we've already seen, what we've measured, what we've discovered in the 120 days since its detection. 8 anomalies, 8 characteristics that violate everything we thought we understood about interstellar objects. 8 reasons why the world's most prominent astrophysicists can't agree on one fundamental question. Is 3I Atlas a comet or something else entirely? Let me take you back to July 1st, 2025, Rio Hurtado, Chile. The ATLAS system, Asteroid Terrestrial Impact Last Alert System, a network of automated telescopes scanning for near-Earth objects. At 0300 hours local time, the Chile telescope flags a moving object, a point of light travelling through the constellation Sagittarius. Fast, too fast. Within hours, astronomers trace its path backward through archived images, pre-discovery observations extending back to June 14th. The object was already there, already moving through our solar system, already heading toward the Sunday. By July 2nd, the calculations are complete. This object isn't bound to our star. Its trajectory is hyperbolic, eccentricity greater than 1. It's not in orbit around the Sun, it's just passing through. It came from interstellar space, and it's going back to interstellar space. This is only the 3rd time in human history we've detected such an object. The first was Oumuamua in October 2017. The second was 2I Borisov in August 2019. And now, 6 years later, we have 3I Atlas. But 3I Atlas is different, immediately, disturbingly different. When astronomers measure its velocity, they record 61 kilometers per second relative to the Sunday. That's 137,000 miles per hour. Faster than Oumuamua, which moved at 26 kilometers per second. Faster than Borisov at 32 kilometers per second. Each successive interstellar visitor arrives with progressively higher speed. Why? What mechanism in the galaxy accelerates objects to these velocities? And then there's the age. When they analyze its trajectory, when they trace it backward through space and time, they calculate its journey duration, 7 billion years. This object has been travelling through the void for 7 billion years. Our Sun is 4.6 billion years old. Earth is 4.5 billion years old. When 3i Atlas began its journey, our solar system didn't exist. The sun hadn't formed. The atoms that would become your body were still scattered across a primordial nebula. This object is older than almost everything in our cosmic neighborhood. It has drifted through the galaxy for incomprehensible timescales, crossing unimaginable distances, passing through regions of space we can barely fathom. And now, by cosmic chance or cosmic design, it's here. To understand what makes this so extraordinary, we need context. Oumuamua was strange, elongated, tumbling, accelerating in ways gravity alone couldn't explain, roughly 100 meters long, about the size of a football field, red in color, pancake-shaped. It appeared, flew past, and vanished within weeks. We barely had time to point our telescopes before it was gone forever. The scientific community erupted. For the first time, we had proof that objects from other star systems regularly passed through ours. How many had we missed? How many passed through every decade, every year? 2I, Borisov, was different. It looked like a comet, a normal comet, nucleus, coma, tail. Everything about Borisov said typical cometary behavior just from somewhere else. It was strange but familiar, alien but understandable, which made everyone breathe easier. Okay, we thought. Interstellar objects are just comets and asteroids from other star systems. Mystery solved. Then 3i Atlas arrives, and nothing about it makes sense. July 21st, 2025. NASA's Hubble Space Telescope captures the first high-resolution image. The object is 277 million miles from Earth. Hubble sees a teardrop-shaped cocoon of dust and gas, a bright nucleus, and something that makes the observation team go silent. A jet, a plume extending from the nucleus, but not away from the sun the way every comet's tail extends. This jet points toward the Sunday. They call it an anti-tail, and it's not an optical illusion, it's real. Material is being ejected from 3i Atlas in the direction of the Sunday 10 times longer than it is wide, defying the basic physics of cometary behavior. Anomaly number 1. The anti-tail. A forward jet that shouldn't exist. August 6th, 2025. The James Webb Space Telescope turns its infrared instruments toward 3i Atlas. The team is hunting for chemical signatures, water ice, carbon monoxide, methane, the usual volatile compounds. What they find shouldn't exist. Carbon dioxide, lots of it, water ice, very little. The ratio 8:1, 8 parts carbon dioxide to 1 part water. No comet in our solar system has ever shown this ratio, not even close. The typical ratio is reversed more water than CO2, sometimes 10:1 water, sometimes 20:1. But 8:1 carbon dioxide to water? Never. Anomaly number 2. Chemical composition unlike any comet ever observed. A CO2 to water ratio suggesting formation in an environment radically different from our solar system. What we're seeing is a pristine time capsule from another star system. A chemical fingerprint of conditions that existed 7 billion years ago in a region of space hundreds or thousands of light years away. 3 Atlas is teaching us something fundamental. Not all solar systems are alike. Not all comets form the same way, unless it's not a comet at all. July 23rd, 2025. The European Very Large Telescope in Chile begins spectroscopic observations. They're looking for metal emissions, trace amounts of iron and nickel that comets release when heated by the sunday. At a distance of 3.78 astronomical units, nearly 4 times the Earth-Sun distance, the team detects emission lines, spectral signatures in the ultraviolet range, nickel, atomic nickel vapor glowing in the thin atmosphere surrounding 3I Atlas. This shouldn't be possible. At that distance, the temperature is far too cold for nickel to vaporize. Nickel sublimes at roughly 2800 degrees Celsius. At 3.78 AU, surface temperature is around negative 80 degrees Celsius. The numbers don't work. August 24th. The Keck 2 telescope in Hawaii captures more detailed spectra. The team zooms in on metallic emissions. They're looking for iron. Every comet that shows nickel also shows iron. The two metals, they're created together in supernova explosions. They exist together in meteoritic material. They should always appear together, always. 3I Atlas shows nickel. Prominent, unmistakable nickel emission lines. But iron, nothing. No iron lines. None. The team runs the data again. Different wavelengths. Different instruments. Same result. Nickel without iron. A chemical signature that in nature should not exist. Dr. R.V. Loeb, astrophysicist at Harvard University, studies the data. He's seen this signature before, but not in space. In industrial facilities, in chemical refineries, in a process called the nickel carbonyl pathway, nickel tetracarbonyl, nicocota, a compound used in industrial metal coating and refining, a compound that produces pure nickel without iron contamination, a compound that until now has only ever been created by humans, in laboratories, in factories, never in nature, never in space, never on any comet or asteroid ever observed. Anomaly number 3. Nickel emission without iron. A chemical signature previously observed only in industrial manufacturing processes. The scientific explanation, perhaps the extreme cold of interstellar space, combined with trace carbon monoxide, created conditions for natural nickel carbonyl formation. A chemical pathway that's theoretically possible but never observed. An organic process that mimics industrial refining. It's improbable but possible. Doctor. Loeb proposes an alternative. What if the industrial signature is exactly what it appears to be? What if 3I Atlas is technology? By late August, multiple observatories are tracking 3I Atlas continuously, trying to determine its size. Measuring a comet's diameter is difficult. You're separating the bright coma from the solid nucleus buried inside. Hubble images show a bright region roughly 4,000 kilometers across. But that's the coma, the cloud of gas and dust. The nucleus is somewhere inside. NASA's SphereX Space Observatory measures the coma's expansion over days. From 13,000 kilometers on June 21st to nearly 26,000 kilometers by August, almost twice Earth's diameter. But the nucleus remains hidden. Estimates range from 440 meters to 5.6 kilometers in diameter. Dr. Loeb calculates minimum mass based on observed behavior. For 3I Atlas to maintain its trajectory without detectable non-gravitational acceleration, it must have significant mass, enough to overwhelm any thrust from outgassing. his calculation. Minimum diameter of 5 kilometers. Minimum mass 33 billion tons, making 3i Atlas at least 1,000 times more massive than Oumuamua, at least 100 times more massive than Borisov. Anomaly number 4. Size discrepancy. Why is the third interstellar object 1,000,000 times more massive than the first? Why would the cosmos deliver progressively larger visitors? Perhaps we're experiencing selection bias. Perhaps interstellar space is filled with objects of all sizes and we're detecting larger ones more easily. Perhaps 3i Atlas represents the true norm and Oumuamua was the aberration. Or perhaps size correlates with purpose. A football field size scout in 2017, a house size probe in 2019, and now a Manhattan size mothership in 2025. Progressively larger, progressively more complex, progressively more difficult to explain. September 1st, 2025. Astronomers analyze 3i Atlas's trajectory with increasing precision. They're plotting its path through the solar system, calculating orbital elements, determining approach angle. Every interstellar object should arrive from a random direction. The galaxy is three-dimensional. Stars are distributed everywhere. When an object enters from interstellar space, it should arrive from any angle, up, down, sideways, relative to the plane of the planets. The ecliptic plane, the flat disk containing Earth, Mars, Jupiter and the other planets, represents less than 1% of possible approach angles. Oumuamua approached at 25 degrees to the ecliptic, significantly tilted, random as statistics predict. Borisov approached at 44 degrees, even more tilted. Again, random as expected, 3i Atlas approaches at 5 degrees to the ecliptic. 5 degrees, nearly aligned with the planetary plane. The statistical probability of this alignment occurring by chance, less than 1%. Anomaly number 5, trajectory alignment. 3i Atlas arrives from a direction allowing close approaches to multiple planets, Mars, Earth, Jupiter, while remaining in the ecliptic plane where navigation is easiest. Coincidence? 1% probabilities happen. We've only detected 3 interstellar objects. Sample size too small for conclusions. Or it's deliberate. An object designed to maximize planetary encounters. A trajectory optimized for multi-target observation. A path chosen, not random. When Atlas first detected 3i Atlas on July 1st, it was moving at 137,000 miles per hour, 61 kilometers per second. Fast, but not impossibly fast. Interstellar objects are supposed to move quickly. That's how we identify them. But as 3i Atlas approaches the Sun, it accelerates. Gravity pulls it faster. By late October at perihelion, it will be moving at nearly 250,000 kilometers per hour. Oumuamua moved at 26 kilometers per second. Borisov at 32, 3i Atlas at 61. Each successive interstellar object arrives faster, significantly faster. Anomaly number 6, excess velocity. Why does each visitor arrive with progressively higher speed? Gravitational slingshots around stars, close encounters with massive objects, ejection from binary star systems. Natural processes can impart high velocities. 3i Atlas could have been gravitationally accelerated 7 billion years ago and maintained that velocity through empty space. Or each successive object arrives faster because each generation is more advanced, more powerful, more capable of sustained acceleration. Faster arrival means less warning time, less time to prepare, less time to respond. October 1st, 2025, 3i Atlas crosses the orbit of Mars. The red planet lies directly in its path. This is the opportunity, the chance to see 3i Atlas up close. Closer than any Earth-based telescope can achieve. Orbiting Mars are 7 active spacecraft cameras and spectrometers built to study the planet below. For 1 week, these spacecraft turn away from Mars and point at 3i Atlas instead. October 3rd, 4 UTC. Closest approach. 3i Atlas passes within 30 million kilometers of Mars, roughly 18 million miles. From a Mars orbiter's perspective, the comet is 150 times closer than it will ever appear from Earth. ESA's ExoMars Trace Gas Orbiter captures images with its Cassis camera, 5-second exposures. The comet appears as a fuzzy ball of light against streaked star fields. The glow around 3i Atlas extends roughly 680 kilometers, smaller than Hubble saw from farther away because Cassis can only detect the brightest core. The full coma extends hundreds of thousands of kilometers, invisible to small Mars cameras. NASA's Mars Reconnaissance Orbiter points its HiRISE camera, the highest resolution camera ever sent to Mars, at 3i Atlas. 30 kilometers per pixel, 3 times better than any previous image. The goal: measure nucleus brightness, calculate its diameter, determine its true size. The data is captured, transmitted to Earth, received by NASA and not released. October 8th, October 12th, October 20th, the HiRISE images remain classified, or delayed, or under analysis. NASA offers no explanation. ESA releases low-resolution Cassis images, but no spectroscopic data. China's Tianwen-1 orbiter captures images, not released. UAE's HOPE orbiter observes with infrared spectrometers, no data published. NASA's Perseverance rover on the Martian surface photographs the night sky. Astrophotographer Simeon Schmaus stacks multiple exposures. A faint smudge appears in the expected location, a confirmed sighting from the ground. But the orbital data, the high-resolution images, the spectroscopic analyses, the detailed composition measurements remain locks away. Data processing takes time. Mars orbiters weren't designed to photograph comets. Images require calibration, analysis, peer review. Scientific caution is prudent, or what the Mars orbiters saw can't be easily explained. What they measured doesn't match expectations, and releasing the data would trigger questions nobody is ready to answer. Anomaly number 7. The data blackout. High-resolution observations from multiple spacecraft captured during the optimal observation window remaining unreleased for weeks. October 21st, 2025. Solar conjunction 3i Atlas moves directly behind the Sun as viewed from Earth. The Sun's glare overwhelms any attempt to observe. Coronagraphs can't help. The comet is too close to the solar disk. Space telescopes can't see through the Sunday. Ground-based telescopes are blinded by daylight. From Earth, 3i Atlas becomes invisible. Completely invisible for 3 weeks. And during these 3 weeks, during this period of enforced blindness, 3i Atlas will reach perihelion. October 29th, 2025. 2 days from now, closest approach to the Sunday, 203 million kilometers, 1.4 astronomical units, just inside the orbit of Mars. At this distance, the Sun's radiation delivers 33 gigawatts of power to 3i Atlas's surface. 33 gigawatts equivalent to 1/3 of all nuclear power generated in the United States. Enough energy to sublimate massive amounts of ice, enough energy to trigger violent outgassing, enough energy to power anything. Dr. Loeb calls attention to an effect in orbital mechanics, the Oberth maneuver. When a spacecraft wants to change trajectory most efficiently, it fires engines at perihelion, the point of maximum velocity. Thrust applied at peak speed produces maximum kinetic energy change. If you wanted to alter course, if you wanted to deploy probes, if you wanted to adjust trajectory to intercept Earth, you would do it at perihelion. You would do it while hidden behind the Sunday. Anomaly number 8. Perihelion timing. 3i Atlas reaches closest approach to the Sun at the exact time when Earth-based observation is impossible. The optimal moment for maneuvers coincides perfectly with the observation blackout. Perihelion timing is determined by orbital path. The orbit was set 7 billion years ago. The conjunction is coincidence, random geometry, or the orbit was chosen specifically, an approach trajectory that maximizes the observation gap. Perihelion scheduled during solar conjunction. A window of invisibility deliberately engineered. 3 weeks, October 21st to November 11th. 3 weeks when 3i Atlas is alone with the Sunday. 3 weeks when anything could happen. Dr. Abraham Loeb, Frank B. Baird, Junior Professor of Science at Harvard University, founder of the Galileo Project, former chair of Harvard's Astronomy Department, a scientist who has spent his career studying the possibility of extraterrestrial technology. In July 2025, following 3i Atlas's discovery, Dr. Loeb proposes a classification system, the Loeb scale, 0 to 10. 0 means definitely natural, a rock, a comet, an asteroid. 10 means definitely technological artificial radio signals, visible propulsion, deliberate maneuvers. Everything in between is uncertainty. Oumuamua scored a 2. Unusual shape, unexplained acceleration, but probably natural, probably. Borisov scored a 1. Normal comet just from somewhere else, definitely natural. 3i Atlas scores a 4. 40% likelihood of non-natural origin. Not proof of technology, not confirmation of artificial design, just elevated probability. Higher than chance, lower than certainty. 4 means take it seriously, watch carefully, don't assume. 8 anomalies, each one individually explainable through unlikely but possible natural processes, but together, stacked, cumulative, the probability of all 8 occurring simultaneously in one object by pure chance, less than 1 in 10,000. But 1 in 10,000 events happen every day, somewhere in the universe. Improbable doesn't mean impossible. We live in a cosmos of infinite dice rolls. Eventually, the unlikely becomes inevitable. Or the 8 anomalies aren't separate, they're connected. Different aspects of the same underlying truth. A truth we're not ready to accept. November 4th, 2025, 8 days from now. ESA's Jupiter Icy Moons Explorer JUICE passes within 64 million kilometers of 3I Atlas. The spacecraft is en route to Jupiter's moons, but for one day it turns its instruments toward the interstellar visitor. JUICE carries a full suite: Janus Visible Imager, Magis Infrared Spectrometer, SWI Submillimeter Wave Instrument, UVS Ultraviolet Spectrograph. Every sensor capable of detecting 3I Atlas turns on. This is the first observation after perihelion, the first chance to see what happened during the 3-week blackout. Did 3I Atlas fragment like a natural comet under solar stress? Did it eject smaller objects? Did its trajectory change? JUICE captures data, gigabytes of measurements, images, spectra, thermal readings. But JUICE is far from Earth. On the opposite side of the Sun day, using its high-gain antenna as a heat shield, transmitting on low bandwidth channels, data transmission rate minimal, the observations won't reach Earth until February 2026. 3 months away, November 11th, 2025, 2 weeks from now, 3I Atlas emerges from behind the Sunday visible, again from Earth. Morning sky, eastern horizon, just before dawn. Telescopes around the world lock onto it immediately. 8-inch telescopes, 10-inch, 12-inch. Amateur astronomers and professional observatories alike, what do they see? A comet, still intact, still moving on its predicted trajectory. No visible fragments, no secondary objects, no unexplained maneuvers. 3I Atlas looks exactly as it should. A fuzzy blob of light moving through Virgo constellation toward Leo. Magnitude 12 visible through medium-sized telescopes. Fading slowly as it moves away from the Sunday, but absence of visible change doesn't mean nothing changed. Small objects ejected during perihelion would be invisible to ground-based telescopes. Subtle trajectory adjustments would take weeks to detect. Internal modifications would leave no external signature. The fact that 3I Atlas looks normal might be the most suspicious thing of all. December 19th, 2025, 2 months from now, 3I Atlas makes its closest approach to Earth, 1.8 astronomical units, 269 million kilometers, 167 million miles. Still too far for naked eye visibility, still requiring telescopes. But this is it, the closest it will ever come to our planet. After this, 3I Atlas accelerates away, outbound, past Jupiter in March 2026, past Saturn in 2028, past Uranus in 2032, eventually back into interstellar space, gone forever, unless it left something behind. March 16th, 2026, NASA's Juno spacecraft orbiting Jupiter will pass within 54 million kilometers of 3I Atlas. Juno carries magnetometers, particle detectors, microwave radiometers, instruments capable of detecting magnetic fields, electrical activity, non-visual emissions. instruments that can sense things cameras can't see. This will be the last close observation, the final chance to understand what we're dealing with. After Juno, 3 Atlas will be too far away, too faint, too fast for detailed study. By spring 2026, we'll know. One way or another, we'll have answers. But right now, October 28th, 2025, 48 hours before perihelion, we wait, we watch, we measure, we calculate, and we wonder what's really out there. August 24th, 2025. While the Keck 2 telescope captures the nickel without iron anomaly, it detects something else, another emission line, stronger than expected, cyanide, CN radical, carbon bonded to nitrogen, glowing in the ultraviolet spectrum. Cyanide is common in comets, nothing unusual there. Most comets release CN radicals as they approach the sun, organic compounds breaking down in solar radiation, but the concentration in 3 I Atlas is elevated. The cyanide extends outward from the nucleus in an exponential profile, 840 kilometers, farther than the nickel, which concentrates closer to the core at 600 kilometers. This layering suggests different source mechanisms. The nickel sublimates from the surface. The cyanide originates from deeper within, from interior ices, vaporizing and escaping through cracks and vents. Or the cyanide is deliberately released, an exhaust signature, a propellant byproduct. Cyanide compounds have been proposed as potential interstellar fuel sources. Hydrogen cyanide HCN can be polymerized into complex molecules that store chemical energy. Under the right conditions, CN-based chemistry could theoretically power low-thrust propulsion systems. But that's theoretical. No human technology uses cyanide propellants. We've never built anything that emits CN radicals as exhaust, which means either we're observing natural cometary chemistry we don't fully understand, or we're detecting technology based on principles we haven't invented yet. Both options are unsettling. September 15th, 2025, lunar eclipse. The moon passes through Earth's shadow. Amateur astronomers worldwide point telescopes at the darkened moon and surrounding stars. 3 Atlas is visible that night, low in the southern sky, magnitude 13, faint but detectable with 8-inch telescopes under dark skies. Astrophotographers capture long exposures, stacked images, multiple frames combined to enhance faint details. And in those images, 3 I Atlas glows green. Not white, like most comets, not blue like some, green. A distinct green luminescence surrounding the nucleus. Green comets are rare, but not unknown. The colour comes from diatomic carbon-C, 2 molecules fluorescing in sunlight. When UV radiation hits carbon molecules in the coma, they absorb energy and re-emit it as visible green light. Comet Lovejoy in 2014 glowed green. Comet Swan in 2020. It's documented, explained, but there's something different about 3 I Atlas's green glow. The intensity. Normal green comets show moderate C2 emission. 3 I Atlas shows intense C2 emission despite having low overall carbon monoxide levels. The CO to C2 ratio is inverted from what's typically observed. How does a comet produce abundant diatomic carbon without abundant carbon monoxide precursor? Where is the C2 coming from? One possibility, the carbon isn't coming from ice sublimation. It's coming from surface materials, from carbonaceous compounds embedded in the nucleus, from organic polymers breaking down under solar radiation, or from something manufactured, something designed to produce visible emissions. A beacon, a marker, a signal. Imagine you're an interstellar probe, 7 billion years in transit. You need to be tracked, monitored, identified from a distance. How do you make yourself visible across astronomical distances? You glow, you emit light at wavelengths that stand out. You create a signature that says, I'm here. 3i Atlas glows green. In the darkness of space, against the black background, it announces its presence. The question is, to whom? July through September 2025. The Teide Observatory in the Canary Islands tracks 3i Atlas nightly. Photometric observations measuring tiny changes in brightness over time. As 3i Atlas rotates, different faces reflect varying amounts of sunlight. If the nucleus is spherical, brightness remains constant. If it's elongated or irregular, brightness oscillates as it spins. The Teide data shows periodic variation. Amplitude 0.3 magnitudes. Period 8 hours. 8-hour rotation period. One complete rotation every 8 hours. And the 0.3 magnitude variation suggests an elongated nucleus longer than it is wide, possibly 2:1 axis ratio, maybe 3:1, like Oumuamua. Remember Oumuamua? Oumuamua was elongated, extremely elongated, 10:1 axis ratio, like a cigar or a needle or something else. It rotated every 8 hours as well, and it accelerated without visible outgassing. Two interstellar objects, both elongated, both rotating every 8 hours, both showing unexplained properties. Coincidence? Elongated shapes are common in small bodies. Asteroids are often irregularly shaped. Comets develop lobes and ridges from uneven sublimation. 8-hour rotation isn't particularly special, it's within the normal range for kilometre-sized objects. There's nothing inherently suspicious about an elongated, rotating nucleus, unless elongation isn't random, unless it serves a purpose. A long, narrow structure maximizes surface area for solar panels, or for heat dissipation, or for antenna arrays. Rotation provides stability, gyroscopic effect, artificial gravity along the long axis, directional control. If you were designing an interstellar probe, something that needs to function for billions of years in the vacuum of space, you'd make it elongated. You'd spin it for stability. You'd give it an 8-hour rotation period, exactly like 3 Atlas. September observations from multiple observatories measure the polarization of sunlight scattered by 3 Atlas's dust coma. When light scatters off dust grains, it becomes polarized. The amount depends on size, shape, and composition of the dust. Normal comets show polarization of 10 to 20% at certain angles. 3i Atlas shows 30 to 40%, nearly double the expected value. High polarization indicates either very small dust grains, submicron particles, or unusual grain composition. Maybe carbonaceous material, maybe metallic particles, maybe something we haven't encountered before. Small grains are interesting. Very small grains scatter blue light preferentially. They'd make the comet appear bluish. But 3i Atlas appears green, so the grains aren't that small, which leaves composition. The dust itself is different, chemically anomalous, made of materials that don't exist in solar system comets, or made of materials that don't exist in nature at all. Advanced civilizations could use engineered nanomaterials, graphene, carbon nanotubes, metamaterials with properties designed for specific functions. Imagine a probe's outer surface coated with microscopic structures optimized for thermal regulation, or electromagnetic shielding, or radiation protection. As the probe approaches the sun, this coating ablates, sublimates, releases engineered particles into space, creating a coma that looks like natural dust but with anomalous optical properties, high polarization, unusual scattering, signatures that don't quite match natural materials. We're measuring these properties, recording them, publishing papers, and slowly accumulating a list of inconsistencies. Not proof, just anomalies. So here we are, October 28th, 2025, 48 hours until perihelion, 48 hours until 3i Atlas reaches its closest point, the Sunday, 48 hours until it disappears behind solar glare for 3 weeks. During those 3 weeks, anything could happen. A natural comet could fragment under solar stress, or a technological object could perform an O-berth maneuver, deploy probes, release payloads, change trajectory, and we won't see any of it. 8 anomalies, 7 billion years, 1 mysterious visitor, and 2 fundamental questions. Where did it come from? And why is it here? In part 2, we'll explore the theories, the technology hypothesis, the mothership scenario, the philosophical implications, what it means if Dr. Loeb is right, what it means if we're not alone, and what it means if they've been watching us for 7 billion years. But right now, in this moment, all we can do is wait. The countdown has begun. 48 hours. 48 hours until 3i Atlas and the sun meet in secret. And we're left wondering what will emerge from that encounter. Because on November 11th, when 3i Atlas reappears in Earth's morning sky, it might look exactly the same. Or it might be completely different. And we won't know until it's already happened. That's what makes this moment so extraordinary and so terrifying. We're standing at the edge of potential first contact, or we're observing a completely natural cosmic coincidence. And the only way to find out, which is to wait, to watch, to measure, and to hope that whatever happens during these next 48 hours doesn't change everything we thought we knew about our place in the universe. An object 7 billion years old moves through our solar system. 8 documented anomalies, industrial metal signatures, perihelion passage during solar conjunction. 48 hours from now, it reaches the Sunday, and 3 fundamental questions remain unanswered. Where did it come from? What is it made of? And why is it here? Let's talk about what happens if Dr. Loeb is right, If there's even a small probability, say 30 to 40%, that 3i Atlas isn't natural, if it's technology, if it's a probe sent by an ancient civilization to study our solar system, what would that mean? What are the implications? First, the mothership hypothesis. Dr. Loeb's full theory goes like this. 7 billion years ago, an advanced civilization in a distant star system detects something interesting. A molecular cloud about to collapse. A stellar nursery forming. New stars and new planets about to be born. They want to study this process. They want to observe the formation of the solar system. But it's hundreds or thousands of light years away. They can't travel there themselves, not in reasonable time. So they send probes, self-replicating, autonomous, long-duration probes designed to survive billion-year voyages. No crew, no life support, just sensors, computers, and a mission. Reach the target star system, monitor its development, report findings. The probe accelerates to a significant fraction of light speed, maybe 1%, maybe 5%, using technologies we can't fathom. Fusion drives, antimatter rockets, light sails pushed by orbital lasers. After millennia of acceleration, it cruises 7 billion years at constant velocity, through the void, through the dark, alone. Think about that. 7 billion years. The entire history of Earth, from primordial ocean to human civilization, happens twice over during the probe's journey. Mountains rise and erode. Species evolve and go extinct. The galaxy itself changes shape, and the probe just flies, waiting, silent, patient beyond comprehension. Eventually, it arrives. 4.6 billion years ago, the solar system is forming, the proto-sun ignites, planets accrete from the proto-planetary disk. The probe watches. It observes Earth's formation, the late heavy bombardment, the emergence of liquid water, the spark of life, the great oxygenation, the Cambrian explosion, the dinosaurs, the extinction events, the rise of mammals, the evolution of humans. It watches all of it, recording, analysing, waiting for the moment when the target civilization becomes detectable, becomes technological, becomes interesting. And now, 2025, we are detectable. We have radio telescopes. We have space probes. We have cities lit up at night, visible from space. We're on the edge of becoming an interplanetary species. So the probe does a flyby, comes in close, collects data, measures our electromagnetic emissions, samples our atmosphere, photographs our cities, and then it leaves, mission complete, heading back toward interstellar space, carrying 7 billion years of observations about the solar system's evolution, including us. If this hypothesis is correct, 3 Atlas is a messenger, not to us, for someone else, carrying information about us to a civilization so ancient, so distant, so far beyond our comprehension that we can't even imagine what they would do with that information. But most astronomers reject the technological hypothesis. The consensus view, 3I Atlas is a comet. An unusual comet, yes, but still natural, still explainable through conventional astrophysics. Dr. Michele Bannister planetary astronomer at the University of Canterbury, points out that we've only detected 3 interstellar objects. 3. That's not enough for statistical analysis. With such a small sample size, anomalies are expected. Dr. Jason Wright, Professor of Astronomy at Penn State, notes that solar system comets show enormous variation, different compositions, different behaviors, different chemistries. An interstellar comet from another star system should naturally be different from ours. The nickel without iron signature, Dr. Damien Hutsemakers of the University of Liège proposes a natural carbonyl process. At the extreme cold of interstellar space, nickel could bond with carbon monoxide molecules on the comet's surface. As the comet warms approaching the Sun, nickel carbonyl forms and decomposes, releasing pure nickel vapor. It's unprecedented, but not impossible. The anti-tail could be perspective effect combined with unusual dust grain sizes, or a secondary tail created by radiation pressure on nanoparticles, or a jet aligned by the comet's rotation. The 8:1 CO2 to water ratio indicates formation in a carbon dioxide rich region of a protoplanetary disk. Different star, different chemistry, different ice composition. Everything can be explained. Every anomaly has a natural mechanism. Unlikely, yes, but possible. Science requires extraordinary evidence for extraordinary claims. The burden of proof is high, deliberately, rightfully high. We don't invoke aliens every time we see something we don't understand. But here's the uncomfortable truth. The evidence for 3 Atlas being technological is exactly the same as the evidence for it being natural, ambiguous, circumstantial, inconclusive. We see what we expect to see. Astronomers trained to study comets see a comet. Astrobiologists searching for technosignatures see potential technology. Both interpretations fit the data. Neither is proven. Neither is disproven, which means the only honest answer is, we don't know. If 3 Atlas is technology, it raises an even more disturbing question. Where is everyone? The Fermi paradox, named for physicist Enrico Fermi. The contradiction between high probability of extraterrestrial civilizations and 0 evidence of their existence. The galaxy is 13.6 billion years old. Billions of stars, billions of planets, billions of opportunities for life to emerge. And life, once started, tends to spread, to expand, to colonize. If even one civilization in the galaxy had achieved interstellar travel 1 billion years ago, they would have colonized the entire galaxy by now. Every star, every planet, every asteroid belt, including ours. But we see no evidence of galactic civilizations, no megastructures, no Dyson spheres, no obvious astroengineering. The galaxy looks empty, dead, quiet. This is the great silence. The absence of anyone answering our radio signals. The emptiness where we expected to find neighbours, and it's terrifying. Maybe intelligent life is rare. Maybe Earth is special. Maybe consciousness is a cosmic fluke. Maybe intelligence is common but self-destructs. Nuclear war, climate collapse, AI catastrophe. Maybe civilizations extinguish themselves before achieving interstellar travel. Maybe interstellar travel is impossible. Maybe the speed of light is a hard limit nobody can overcome. Maybe the distances are too vast, the energy requirements too high, the challenge is insurmountable. Or maybe they're here, They've always been here, watching, monitoring, studying. From a distance, using probes so advanced we can't distinguish them from natural objects. Maybe 3i Atlas is one of thousands. Maybe interstellar space is filled with ancient, autonomous probes. Maybe every star system in the galaxy has been surveyed. Maybe we've been under observation since the moment multicellular life emerged on Earth. Maybe the great silence isn't silence at all. Maybe it's discretion. Maybe they don't talk to us because we're not ready, or because we're irrelevant, or because we're subjects in an experiment that requires non-interference. Or maybe they're waiting, watching for something, some threshold, some milestone, some moment when we cross from primitive to interesting. And maybe that moment is now. There's a specific answer to the Fermi paradox called the zoo hypothesis, proposed by MIT radio astronomer John Ball in 1973. The idea is simple. Advanced civilizations exist. They're everywhere. But they've agreed not to contact primitive species. They maintain a quarantine, a preserve, a zoo. Earth is the exhibit. We're the animals, kept in our enclosure, monitored but not contacted, observed but not interfered with. Why? Maybe for ethical reasons. Maybe they've learned that contact with less advanced civilizations causes harm. Cultural contamination, technological disruption, psychological trauma. Maybe first contact is dangerous. Maybe species that aren't ready for the truth about the universe break, collapse, self-destruct. If the zoo hypothesis is correct, 3i Atlas makes perfect sense. It's a caretaker, a park ranger, checking on the exhibits, making sure the primitive species is developing normally. We've reached a critical juncture. Nuclear weapons, climate change, artificial intelligence, genetic engineering. We're approaching technologies that could either destroy us or elevate us. So the probe comes by, takes measurements, assesses our progress, files a report. Are humans advancing responsibly? Or are they heading towards self-termination? And depending on that assessment, maybe the zoo's policy changes. Maybe the quarantine is lifted. Or maybe the exhibit is closed. The experiment is terminated. The species is deemed a failure. We assume first contact would be enlightening, inspiring, the beginning of humanity's cosmic story. But maybe first contact is judgment, an evaluation we might fail. Let's talk about the 8-to-1 ratio. CO2 to water ice. Why does this matter so much? Water is the universal solvent, the medium for biochemistry. Every life form on Earth requires water. Every hypothesis about extraterrestrial life assumes water availability. Comets are considered potential delivery vehicles for Earth's water. The oceans might have come from cometary impacts during the late heavy bombardment, water-rich comets crashing into the primordial Earth, filling the basins, creating the seas. 3i Atlas has very little water, minimal H2O. Instead, it's dominated by carbon dioxide, dry ice, a compound that's useful for cooling, for propulsion, for creating sublimation, thrust, but not for life, not for biology, which suggests one of two things. Either 3i Atlas formed in a stellar environment radically different from ours, a protoplanetary disk with unusual chemistry, perhaps around a carbon-rich star or in a molecular cloud with elevated CO2. Or it was never meant to support life. It's machinery, equipment, a vehicle designed for function, not biology. A probe built by a civilization that doesn't think in terms of water-based chemistry. Maybe they're silicon-based. Maybe they exist at cryogenic temperatures. Maybe their biochemistry uses methane or ammonia as a solvent instead of water. Maybe they look at Earth, this warm, wet, oxygen-rich planet, the way we look at Venus. Hostile, incompatible, alien. If 3i Atlas is technology, the chemistry tells us something profound. Its builders are nothing like us. They operate under different physical and chemical constraints. Their biology, if they still have biology, follows rules we haven't imagined, and that's simultaneously wonderful and terrifying. There's another possibility, one we haven't discussed enough. 3i Atlas might not survive perihelion intact. Comets break apart. It happens. The stress of solar heating, differential expansion, thermal shock, internal pressure from sublimating ices can fracture a comet's nucleus. Comet Shoemaker-Levy 9 broke into 21 pieces before crashing into Jupiter in 1994. Comet Lineaire disintegrated in 2000. Comet Ison vaporized at perihelion in 2013. If 3i Atlas fragments during or after perihelion passage, we'd see multiple objects spreading apart, a trail of debris, a cluster of smaller nuclei following similar trajectories. This would happen naturally to a weakly bound comet approaching the Sun too closely. Structural failure, gravitational tides, rotational stresses. Or it would happen deliberately, a mothership releasing multiple subprobes, each one targeted at different solar system locations, each one with independent mission parameters. From Earth, we couldn't tell the difference. Fragmentation looks the same, whether it's accidental or intentional. Dr. Loeb calls this the dandelion scenario. A dandelion flower produces hundreds of seeds, each one equipped with a little parachute. When the flower matures, the seeds disperse, carried by wind to different locations, each one capable of growing into a new plant. 3i Atlas could be a cosmic dandelion approaching the solar system, reaching perihelion, and at that moment release the seeds, scatter them throughout the inner planets, small objects, masses in the hundreds or thousands of kilograms, given just enough velocity to reach Mars, Earth, Venus, even the asteroid belt, each one a miniature probe, landing, observing, transmitting data somewhere. November observations showed no obvious fragmentation, no visible secondary objects, but that doesn't mean it didn't happen. Objects smaller than 100 meters are undetectable at interplanetary distances with ground-based telescopes. They could be out there right now, dozens of them, inbound, silent, invisible, arrival date unknown. Let's assume for a moment that Dr. Loeb is right, that 3i Atlas is technology, that it released probes during perihelion, that some of those probes are headed toward Earth. What do we do? This is the question nobody wants to ask, because asking it means taking the hypothesis seriously. And taking it seriously means acknowledging we might be completely unprepared. We have no protocols for interstellar contact. The United Nations has no official policy. NASA has no procedures. SETI, the Search for Extraterrestrial Intelligence, focuses on radio signals, not physical objects. If a probe enters Earth's atmosphere, who responds? The military, scientists, politicians? Who makes decisions? Who speaks for humanity? And what do we do if the probe doesn't want to communicate? What if it just observes, takes samples, records data, and then leaves? Or worse, what if it doesn't leave? This is hypothetical. No evidence suggests probes are incoming. No radar systems have detected anomalous objects. No satellites have photographed anything unusual. We're safe, probably, almost certainly, but the fact that we're even having this conversation, that serious scientists are discussing interstellar probe scenarios, indicates something has changed. We're not as alone as we used to think. The universe is not as empty. The probability of contact has shifted from zero to non-zero, and once a probability becomes non-zero, it's only a matter of time. In response to Oumuamua and the possibility of interstellar technology, Dr. Loeb founded the Galileo Project in 2021. The mission: systematically search for evidence of extraterrestrial technological artifacts. Multiple observatories around the world, wide-field cameras, all-sky monitoring, algorithms designed to detect anomalous objects in near-Earth space. The Galileo Project treats UFO reports, now called UAPs, unidentified aerial phenomena, as a scientific question, not a fringe topic. If pilots are reporting objects with impossible flight characteristics, let's collect data, let's measure, let's investigate properly. Since 3i Atlas's discovery, the Galileo Project has intensified monitoring, watching for objects that don't match natural trajectories, hunting for signatures of advanced propulsion, recording atmospheric anomalies. So far, nothing definitive. Lots of ambiguous data, lots of objects that could be mundane, satellites, debris, atmospheric phenomena, but nothing that screams technology. But absence of detection doesn't mean absence of presence. It might just mean we're not looking in the right way, or at the right wavelengths, or with sufficient sensitivity. The Galileo Project represents a shift in scientific culture. For decades, searching for alien technology was career suicide. Now it's mainstream, Harvard-backed, funded, legitimate. Whether 3i Atlas is technology or not, it's forced the scientific community to take these questions seriously, and that's progress. March 16th, 2026, 5 months from now, NASA's Juno spacecraft, orbiting Jupiter, will make its closest pass by 3i Atlas. 54 million kilometers, about 1/3 the Earth-Sun distance. Juno isn't designed to study comets. It's designed to study Jupiter's magnetosphere, its auroras, its internal structure. But for one day, mission controllers will repurpose its instruments. MWR microwave radiometer can detect thermal emissions, temperature gradients, heat sources beneath the surface, jade and Jedi particle detectors, can measure charged particles, plasma density, electromagnetic fields. Magnetometer can detect magnetic fields, even weak ones, even artificial ones. If 3i Atlas is technology, Juno might detect it. Not through visible light, not through spectroscopy, but through signatures we can't fake with natural processes, localized magnetic fields, regular electromagnetic pulses, thermal hotspots inconsistent with solar heating patterns, particle emissions that don't match cometary outgassing. This is the final test. The last observation before 3I Atlas moves too far away to study. After March 2026, it's gone. Beyond the outer solar system, into interstellar space, forever. So this is our chance, our last chance to know. Imagine the moment. March 16th, 2026. Juno's data streams back to Earth. Scientists gather at NASA's Jet Propulsion Laboratory, and there, buried in the magnetometer readings, or the particle counts, or the thermal maps, they see it, a pattern, a structure, a signature that says this is not natural. The room goes silent, because in that moment everything changes. Humanity's place in the cosmos, our understanding of life's prevalence, our assumptions about being alone, all shattered by one data point, one undeniable measurement. Or Juno sees nothing. Normal magnetic field, standard particle distribution, temperature profile consistent with solar heating. All data points matching natural comet models, and we're left with uncertainty. Again, always, forever. Not knowing is worse than knowing the truth, even if the truth is terrifying. Let's address the speed question more carefully. When 3 Atlas was discovered on July 1st, it was moving at 61 kilometers per second relative to the Sunday. That's its speed at infinity, the velocity it had in interstellar space before falling toward our star. This number is important because it tells us about the object's origin and history. Objects ejected from our solar system by gravitational interactions with planets typically leave at speeds around 10 to 20 kilometers per second. Objects from other stars arriving here should have speeds in the range of 20 to 50 kilometers per second, roughly matching the orbital velocities of stars in the galaxy. 3I Atlas at 61 kilometers per second is on the high end, but not impossible. Maybe it originated from a young, massive star cluster where stellar encounters are more violent. Maybe it was gravitationally accelerated by a close pass near a massive object billions of years ago. Maybe it's been falling through the galaxy's potential, gaining speed. Natural explanations exist. But the fact remains, each successive interstellar visitor has arrived faster. First Oumuamua at 26, then Borisov at 32, now 3I Atlas at 61. The trend is undeniable. If this trend continues, the fourth interstellar object we detect might arrive at 80 or 100 kilometers per second, the fifth at 150. Eventually, we'll detect something moving at a significant fraction of light speed, and at that point natural explanations become strained, because there are very few natural processes that can accelerate macroscopic objects to relativistic velocities. Supernova explosions, black hole tidal disruption events, direct radiation pressure from extremely luminous stars. These mechanisms exist, but they're rare and violent. They should produce small, fast-moving fragments, not large, intact objects. So if the velocity trend continues, if we keep detecting bigger and faster interstellar objects, the technological hypothesis becomes harder to dismiss. Not proven, never proven without direct evidence, but less easily rejected. The Bayesian probability shifts, the prior assumptions change, and the scientific community has to seriously consider the possibility that some interstellar objects aren't natural debris, but purposeful vehicles. Now let's talk about something we haven't addressed, the political and social implications. Suppose the data from the Mars flybys gets released tomorrow. Suppose it shows something unambiguous, an artificial structure visible in the high-rise images, a geometric pattern, surface features that can't be explained by natural processes. What happens next? First, denial. A significant fraction of the population won't believe it. They'll claim the images are fake, manipulated, misinterpreted. They'll invoke conspiracy theories, government cover-ups, elaborate hoaxes. This is predictable and probably unavoidable. Humans are pattern-matching machines. We see faces in clouds, structures on Mars, canals on Venus. We're predisposed to false positives. So skepticism is warranted, healthy even. Second, panic. Another fraction will react with fear if 3 Atlas is artificial, if alien technology is in our solar system right now. What does that mean for Earth's security? Are we being invaded, studied, harvested? The history of human civilizations meeting for the first time is not reassuring. Usually, the more advanced civilization dominates, exploits, or destroys the less advanced one. Why would alien contact be different? Third, fascination. Scientists, engineers, curious minds worldwide will demand more data. They'll want to study the object, understand its technology, reverse engineer its principles. The scientific value of confirmed alien technology would be incalculable. Every field would be revolutionized. Physics, chemistry, biology, computer science, material science. We'd have proof that our theories about the universe are incomplete, that there are physical principles we haven't discovered, that intelligence and technology can arise through completely different pathways. But here's the problem. All 3 reactions happen simultaneously, and they conflict. The deniers demand suppression of the data, the panicked demand military response, the fascinated demand open investigation. Political leaders have to navigate this chaos while making decisions with incomplete information under time pressure. It's a recipe for disaster. This is why many scientists privately hope 3 Atlas is natural. Not because we're afraid of alien life. Most scientists will be thrilled by confirmed extraterrestrial intelligence, but because we're afraid of human reaction to it. We're not ready. Socially, politically, psychologically, we're not prepared for the paradigm shift that confirmed alien technology would trigger. Better to have another decade, another century, to mature as a species, to unify as a civilization, to develop the wisdom necessary to handle such a revelation. But the universe doesn't care about our readiness. If 3i Atlas is technology, it's here now, ready or not. Let's examine the best case scenario. 3i Atlas is a probe. It studied us. It's leaving. It doesn't interfere. It doesn't communicate. It just observes and reports. This would be the minimal impact first contact. We'd know we're not alone. We'd know intelligence exists elsewhere. We'd know we're being monitored. But our day-to-day lives wouldn't change. The economy doesn't collapse. Governments don't fall. Religions adapt or don't. Life continues. In fact, this scenario is arguably optimal. We get confirmation of extraterrestrial intelligence without the trauma of direct contact. We have time to adjust our worldview gradually. Scientists get data to study whatever we can learn from 3i Atlas's trajectory, composition, behavior, and the knowledge that we're being observed might motivate us to get our act together, to solve climate change, to reduce nuclear arsenals, to become a civilization worth watching. The worst case scenario, 3i Atlas, is a warning or a weapon. 7 billion years is a long time to hold a grudge, but maybe that's how long it takes for interstellar legal systems to operate. Maybe Earth did something billions of years ago when microbial life first emerged that violated galactic law. Maybe the origin of life here was a contamination event. Maybe some ancient civilization seeded Earth with biology and now they're checking on their experiment. And maybe they don't like what they see. This sounds paranoid. It probably is paranoid. But the point is, we don't know. We have no framework for understanding the motivations or ethics of a civilization 7 billion years more advanced than us. They might be benevolent. They might be indifferent. They might be hostile. We can't assume anything, and making assumptions could be dangerous. So what should we do? In the absence of clear evidence either way, the rational approach is preparation without panic. Continue observing 3i Atlas. Collect all possible data. Analyze it rigorously. Publish findings openly. Let the scientific community debate and reach consensus. Meanwhile, quietly develop protocols for various scenarios. What if we detect signals? What if we detect more probes? What if something lands on Earth? These protocols don't have to be military. In fact, they probably shouldn't be primarily military. They should be diplomatic, scientific, and communication focused. We need linguists, anthropologists, psychologists, philosophers. We need people who think about how different minds might think, how different values might value, how different purposes might purpose. And we need humility. The recognition that we're late to this party. If there's a galactic community out there, they've been doing this for millions or billions of years. They've solved problems we haven't encountered. They've made mistakes we haven't imagined. They've reached conclusions about life, intelligence, and civilization that might seem obvious to them and incomprehensible to us. One more thought about the dandelion scenario. If 3 Atlas released dozens of miniature probes during perihelion, where would they go? Mars is an obvious target. Geological activity, potential subsurface water, history of possibly habitable conditions. A probe studying the solar system would definitely want samples from Mars. Venus is interesting too. Extreme environment. Runaway greenhouse effect. Atmospheric chemistry unlike anywhere else. Jupiter and Saturn, the gas giants, represent a different category of planet. Studying their atmospheres, magnetospheres, and moon systems would provide data about planetary formation and evolution. And Earth, obviously Earth, the only planet in the solar system with confirmed complex life. The only place with technology using intelligence. A probe studying our system would prioritize Earth above all other targets. So if mini probes were released, at least one of them is probably coming here. When? We don't know. Depends on the velocity imparted during release. Depends on the trajectory. Could be months. Could be years. Could be decades. And when it arrives, what does it do? Does it enter orbit? Does it land? Does it remain hidden? Does it make contact? Again, we don't know. We can't know without more information. But the possibility exists, and the possibility is enough to warrant attention. The Galileo project is watching. Military radar systems are watching. Amateur astronomers are watching. If something unusual enters near Earth space, we'll probably detect it. Probably. But detection doesn't mean understanding. And understanding doesn't mean control. We might see something we can't explain. We might photograph something we can't identify. And then we're back to the same question. Is it natural or artificial? Is it ours or theirs? So where does this leave us? What have we learned? What do we know? 3I Atlas is real. It exists. It entered our solar system in July 2025. It's 7 billion years old, 5 kilometers in diameter, moving at 61 kilometers per second. Relative to the Sun day, it contains 8 times more carbon dioxide than water. It emits nickel without iron. It glows green. It has an anti-tail pointing toward the Sun day. It arrived aligned with the ecliptic plane, and it reached perihelion while hidden from Earth's view. Is it a comet? Probably. The scientific consensus leans heavily toward natural explanation. Unusual chemistry? Yes. Anomalous behavior? Yes. But still within the realm of possible natural phenomena. Is it technology? Maybe. A small but non-zero probability. 40% if you trust Dr. Loeb's assessment. Enough to warrant serious investigation, not enough to conclude definitively. But here's what we can say for certain. 3I Atlas has taught us that interstellar space isn't empty. Objects cross the void. Ancient wanderers from distant stars pass through our neighborhood, and some of them carry information, chemical compositions that reveal conditions in other star systems, organic molecules that hint at prebiotic chemistry elsewhere, ice ratios that tell us about planetary formation in alien environments. Every interstellar object is a messenger, a bottle cast into the cosmic ocean, a greeting card from stars we'll never visit, a sample free of charge of matter from places we can only imagine. Whether 3I Atlas is technology or not, it's extraordinary. It's a window into the galaxy beyond our borders. A glimpse of diversity we're only beginning to appreciate. But if Dr. Loeb is right, if there's even a small chance that 3I Atlas is artificial, then we need to prepare. Not for invasion, not for conquest, but for contact, for the moment when we're no longer alone, when the hypothesis becomes reality, when the ancient probe delivers its message, and when we have to decide how to respond. March 16th, 2026, Juno's closest approach. 5 months from now, 5 months until we know, one way or another. Until then, we watch, we measure, we calculate, we wait. And somewhere out there, beyond Jupiter, beyond the asteroid belt, beyond the warmth of our sun, 3I Atlas continues its journey, silent, ancient, indifferent, carrying 7 billion years of secrets. The question is, will it ever tell us what they are? Or will we have to figure it out ourselves? Either way, the next few months will determine whether we're alone in the universe or whether we've been under observation all along, whether we're the first intelligence in the galaxy or one of many, whether we're special or ordinary, whether we're children or adults in the cosmic family. And maybe that's the real question 3i Atlas is asking us. Not where did it come from or what is it made of, but who are we? What kind of civilization do we want to be? How do we respond when confronted with the unknown? Do we react with fear or curiosity? Do we close our borders or open our minds? Do we seek to control or to understand? These are the questions that matter, not just for 3i Atlas, but for every future encounter, for every unexplained signal, for every anomalous object, for every moment when the universe reminds us that we're part of something larger than ourselves, something older, something vaster, something we're only beginning to comprehend. October 28th, 2025, 48 hours until perihelion. The countdown continues. And whatever happens next will echo through human history for generations to come.